Good morning, Year 12. This is going to be our final video for the week. I know that I said we were going to be doing 4 videos per week, but I've decided that for the last 2 videos, this one's quite a big one, so this will be basically the last 2 videos in one video, if that makes sense. In other words, this is the last video for the week. It's an important topic, like I've mentioned. We have 3 weeks on our scope and sequence to do this topic, and it only goes up to 7E. So I do want to take my time and go into detail and make sure you understand it. So we are on exercise 7C. I've skipped 7B because 7B is entirely using Excel. Now, what that means is they can't ask you, obviously, an Excel formatting question in your HSC exam. So what I want to do is try and do that lesson when I see you face to face. Obviously, it's not a crucial lesson because, once again, they can't ask you this in a paper exam. However, it's still in the syllabus to look at using annuities with technology. So it is something we are going to come back to. However, I want to push through with the actual information that can be tested in your HSC for now. So we will be coming back to 7B. So 7C, a hugely important lesson today. Expect, no doubt, one of these in your HSC exam, okay? Always going to be in a HSC exam, and they ask these more often than anything else in this topic. So basically, they're future value tables. What they're going to do is give you a table this time to work out your annuity. The reason they do this is we've been doing them by hand without the table, obviously, and we've been creating that recurrence relation. And you've noticed by now it takes some time, right? So basically, they can't ask you to find too many values in the future because it's going to take you a long time, okay? Because you have to do, if they ask for the 10th payment, you're going to have to do 10 of those recurrent relations, which takes up a lot of time. So what they said is, okay, well, we could give the students a table and then we could ask them the 10th payment without them having to work it out. So basically the table is a shortcut. Pardon me. So how do they do this? Well, basically the investment problems with the table, they assume it for every $1. So then if your question is asking you about $500, you're just going to multiply the value by 500. It'll all come together in a second, don't worry. Basically, all you have to do is 3 things in any of these questions. Step 1 is determine the part in the table that you need to know. Okay, so by doing that, you determine the time period, which we represent in financial maths as N, and then the interest rate, which we represent as R. You find that value in the table and then multiply it by whatever your amount of money is. So before I go to that first part, I'll just show you, this is an example. I've taken this question straight out of a HSC exam from the past. This is a question, the table they give you in the question. It says table of future value interest factors. It says up here, and it always will, a table of future value interest factors for an annuity of $1. So basically, you can use this table for any value of any annuity because you just multiply whatever your annuity is by the value, because this is per every $1. So if your annuity was $200, you would times it by 200. If it was 60,000, you'd times it by 60,000. So they create these tables so that you can just adapt it to whatever value your annuity is. So you'll notice the interest rate and then the time period. They could do the interest rate down as the rows and the time periods as a column. It doesn't matter as long as they have some information. Now, all it means is some mathematics person has created these values here for you with a formula. The formula you don't have to know or use. Basically, they've done the recurrence relation so many times. And when you get to advanced and extension, you would actually learn how to calculate these numbers. But for us in standard, we get given all those values. We don't have to know how they got them or why, they just give them to us. So basically all you're going to do is you find your interest rate, you find your time period, and then you go to that section in the table, okay? And then if your annuity is $6,000, you times that by 6,000 and it would give you the future value. So it's really nice and straightforward, okay? So that's just an example for that case. So obviously, depending on whatever rate you have and every time period you have, you just find the different number and multiply it. One thing you do need to be good at, though, is adapting to find the correct R and N value. Now, if you did, which most of you would have done in year 10, 5.3 or 5.2, you would have actually seen some of this before. So let's have a look. So this is just sort of a key idea you do definitely need to know. It's kind of assumed knowledge, but I'm just going to spend some time looking at it. So find the rate and number of time periods for each of the following if X amount of dollars is invested for 5 years at 6% compounded annually. So first of all, I look to myself and I say, okay, annually means per year. My number of time periods and my rate is all per year, so I don't have to change anything. So my rate is 6%, which I know is 0.06. And I know that when I put that, just as a side note, in my formula, it's always 1.06, so I changed it to that 1 point. Well, that's just for the future. And my time periods is 5 years. I didn't have to change anything because everything's in years and the question wanted it per year. So nice and easy. But now what happens is they say, okay, what about biannually or half yearly, or they could say per 6 months. I say, all right, let's look at my rate to start with. My rate is 6% per year. So per half year, I'm just going to divide that by 2. So I'm going to get 3% as my answer, or 0.03. So that's nice and straightforward. 6% per year is going to be 0.03 or 3% per half a year. My number of time periods. Well, think about this. The bank comes into this savings account every half a year. And they look at your savings account and then they give you and they charge you interest, or you earn interest. So if they're doing that for 5 years and they do it every half a year for 5 years, think about how many times in total they're going to be doing that. And you should note that it will be 10 times. So once again, if they're looking at it every half a year, that means they're looking at it twice a year. For 5 years, gives you a total of 10 times. So then, when we go to our table, you would look for the N value of 10 and the R value of 3. And lastly, we've got monthly. So again, my rate. If my rate is 6% per year, I need to find out what it is per month. I'm going to divide it by 12, which would give me 0.5%, or as a decimal, 0.005. My number of time periods, again, think if they're looking at this every month for 5 years, they would be looking at it 12 times a year, times it by the 5 years, overall it would be 60 times. So then in my table, I would be looking at my interest rate of this and my number of time periods of this. Okay? So make sure you are able to adapt. The final one is quarterly, another common one. So per quarter, all right? Things to think about. So, okay, well that's half of a year, or that's 3 months. So, anyway, sorry about that. So, what are we up to? Quarterly. If we're looking at per quarter, so let's think about our interest rate. We know that per year it is 6%. So if I want to split that up into 4, because I want to know it per quarter, then I would just do that, which is going to give me what, 0.15, which as a decimal percent, 0.0015. I think that's right. And number of time periods, again, if they're looking at it per quarter, okay, so they're looking at it 4 times a year, and it's there for 5 years. And again, in my HSC, I would always show that line of working. So they're going to look at it 20 times. So there's my N value and there's my R value. So now let's look at all of this and how we use that idea in the table. The first question here says, use the table to calculate the future value of the following annuities. $12,000 per annum at an interest rate of 4% per annum for 3 years compounded annually. You say, okay, straight away I've got compounded annually, which means everything must be in years. Check, yep, that's in years, done, that's already in years, perfect. On the side, I'm always going to write this. R stays as 4%, which is going to be my, actually I don't even have to change it to a decimal for these because they're already in percentages. So 4%. N is going to be 3. So then therefore my interest factor, and I can just write that as IF. I go, okay, 4%, 3 years, go along my table, down my table, and there's my value. So my interest factor is 3.1216. And remember, you don't need to know what that number means. All you need to know is it's given to you. Some mathematical person has already calculated that that's the number. And now your annuity is $12,000. So therefore, the future value is just going to be my $12,000 multiplied by my interest factor that I found. And that will give me my answer of the future. And I get $37,459.20. So what does that mean? It means that, think about this in real life. If you had $12,000 and you put it into a investment and it was charged at that rate, that time period, compounded annually, you would end up with this value here. All right. The next one, $1,880 per month for 5 months at 12% per annum, and I didn't tell you what it's compounded monthly. You'll notice that the investment annuity value, whatever that was paid, that's what it's usually compounded as. Okay, so you don't have to change the value of money at all, ever. Okay, so let's have a look. We need to do compounded monthly, which means I need both my R and N value per month. Let's have a look. My rate is per annum, my N value is per month, which means I can leave it as 5 because that's already in months, but my rate is per annum, so I need to divide that up into per month, which is going to give me 1%. So now I use 1% and 5 to give me my interest factor. And I'm going to go to my table. 1%, 5 gives me my 5.1010. And these are the solutions I would write exactly how I have in my HSC. The only extra thing I'd add in my HSC is the therefore statement. And just say, therefore, the future value of this annuity is. Okay, and so multiplying my value by that. So it's doing that recurrence relation for you. Okay, it's exactly what we've been doing last lesson. However, it's working all that recurrence relation out for you and just giving you a number instead. So it's easier than what we've been doing. So it's going to grow to 9,589.88. So if you want to, pause the video and give B a go. Okay, just give some room there. Otherwise, let's have a look. And again, I forgot compounded per quarter. And you'll notice that in your textbook, once again, if you didn't understand what I said before, that amount of money is the same as what it's compounded as. So per quarter, I need everything in quarters. I say, okay, my rate, they've given me that per year, so I need to divide that up into 4, which is going to give me 2%. Now my number of time periods, this is interesting. So 18 months, I know that 18 months is 1.5 years. So it's just thinking, well, let's think about this again. If they look at your bank account every quarter of a year, and they have it in there for 1.5 years. Well, think about just 1 year. If they're looking at it per quarter, that would be 4 times. But then half a year, if they look at it per quarter, that would be twice. So it's a total of 6 times that they're going to look at the account. So another way you could think of it is just it's multiplied by 4, which gives you 6 time periods. That would be the hardest one you would be expected to do, I'd say. The best way I think about these is you could think of it as, are you always dividing it by value and the end value always multiplying it by value? Otherwise, I just like to think of it as real life. You know, if they're looking at your account 4 times a year and it's for 1.5 years, it's going to be a total of 6 times. Find your interest factor and then multiply it. And hopefully you got that as your answer. And the last question, this is a level 3 question, okay? It's a bit of a backwards question. So let's have a look at this final question. It says, use the table to find the payment per period if the future value is that at 4% per annum for 5 years. Okay, so it's just a backwards question. So all you're going to do is say, okay, my future value, the answer to this question is $649.956. So what was the value? So basically what it's saying is, if I work backwards, my future value, we know, is that interest factor multiplied by the annuity amount. Now it's saying that, well, what if your future value is $649.956, and you just need to know what the dollar amount of your annuity, your dollar amount of your annuity is. The interest factor, we can see that, we can find that by saying 4% per annum for 5 years. So I'm going to look at 4% and number of time periods being 5. So I get 4%, number of time periods. So my interest factor is 5.4163. 5.4163 multiplied by whatever that annuity amount was. And that's what they want to know. What was that payment, that annuity payment? So think about this as an equation now. 649.956 equals 5.4163 timesing by, let's call it x. I need to get x by itself. I'm going to bring that decimal over. It's timesing, so on the other side I'll divide it. 649.956 divided by 5.4163 is going to give me x. When I divide that, hopefully it works out a nicer number. And it does, just as I hoped, $120. So it's just a backwards question. So if they said, just as we did in the questions above, $120 per year at 4% per annum for 5 years, you would have found that the future value became $649.56. That's as hard as those sort of questions get. And that goes up to your level 3. So have a go at the exercises for me. I've written which ones I want you to do. They do get repetitive, so you are welcome to do every second letter if you want. And by all means, the exercise actually goes up to 11. So if you want more of a challenge, you can continue on through those. Email me if you have any questions or comment below.